Good afternoon, and thank you for joining us today for this media briefing on the upcoming launch of MTG-Imager 2. Before I introduce our expert panelist, a few admin remarks for those of the media who have joined us today. So you will get a chance to ask questions and answers once we've done with a few introductory remarks from the experts. Please remember that you can either raise your hand through the chat function, or you can write it in the chat. Just address it to everyone. Please make sure that you tell us your name and your media when you do so. Now, without further ado, let me introduce our panelists. Joining us today are Caroline Arnoux, head of the Ariane business unit at Ariane Espace, James Champion, MTG project manager at ESA, Susanne Dieterle at MTG system manager at Meteosat, Olivier Brise at MTG program manager at Thales Alenia Space, and Thomas Blackmore, scientific manager at the UK Met Office. Caroline Arnoux, would you like to start off? Thank you.
Thank you, Adelina. So good afternoon, everybody. Ariane Space is currently preparing for a major meteorological mission for European space next week in 8 days on August 27. Ariane 6 will place into orbit the European Meteosat Third Generation Imager satellite, also called MTG-I2. For this launch, we will benefit for a quiet launch window, 2 hours and 30 minutes, which means that the liftoff will take place, if I take the French Guiana local time reference, between 10 past 5 p.m. and 40 past 7 p.m., so Kourou local time. By carrying out this mission, which is called VA270 by Ariane Space, Ariane 6, Europe's sovereign launch capability, will enable the collection of essential meteorological data for forecasting, monitoring, and alert systems, data which are critical to many sectors of everyday life. This Ariane 6 launch, will be also the first Ariane 6 launch in geostationary transfer orbit, so what we call generally GTO mission. A launch in GTO demonstrates again the high-level performance and the versatility of Ariane 6, which has been built to fulfill all our customer needs, and in particular to answer to European institution missions. This mission will be a quite short one, since we will have only one boost of the upper stage, which means that the Vinci, which is the engine which equips the upper stage, will be ignited only once before the satellite separation, and globally the satellite will be separated around 36 minutes after the liftoff. The launch will take place on an Ariane 62 configuration. Ariane 62 configuration meaning that we will have only 2 solid propellant boosters for this mission. It will be the 6th Ariane 6 launch in such a configuration, and it will be also the 4th Ariane 6 launch of the year, knowing that the 3 previous ones were performed with Ariane 64 version of the Ariane 6 launcher. If we go to the launch campaign, perhaps next slide, what we can mention is that the launch campaign is proceeding smoothly and fully according to schedule. In particular, we can mention that MTG-I2 satellite arrived in French Guiana on June 12. The different stages of the launcher arrived by canopy ship in French Guiana on July 14th. Then the launcher was integrated on the launch zone end of July for the central core, and 6 and 7 of August for the solid propellant boosters. The satellite is under preparation in French Guiana, and yesterday it was matted on the adapter being the structure we have between the launcher and the satellite itself. Before the end of the week, the satellite will be integrated inside the fairing, and next Monday, the full upper composite with the satellite inside will be transferred to the launch pad to be matted on the launcher. Then we will be ready for the launch readiness review, which will authorize the start of the chronology, of course, in consistency with the launch on the 26th of August. Thank you for your attention.
Thank you very much, Caroline. Now to give a bit of a perspective from the European Space Agency, James, would you like to take over? Thank you.
Sure. Thank you very much. Get this sorted. Okay, good morning to everybody, or good afternoon if you're in Europe. So hi, I'm James Champion, the European Space Agency project manager for the Meteosat Third Generation projects. I'm joined by Olivier Brise over here from Thales, our prime contractor. So firstly, just a brief overview of the ESA's world-class Earth observation missions. Of course, here's the full range of activities that we're currently involved with, from the science and Copernicus, the very recent ESA-supported and ESA-assisted ones, but of course today we're focused on the meteorological ones on the far right, that we undertake in a very good collaborative way with our cooperative partner EUMETSAT, and you'll hear more from Suzanne in a bit about from their perspective of this mission. But as you can see, we've got quite a lot of satellites happening at the moment. But coming back to MTG, so the Meteosat Third Generation. So once in orbit, MTG-I2 will complete the first family of Meteosat Third Generation satellites, and this will be an auspicious occasion because then we'll finally get the full data set from the full power of the third generation satellites. There'll be 2 imagers and 2 sounders up there at the same time. We have in parallel been building the family 2, and these satellites are almost complete. They're complete at instrument and platform levels, and these are being slowly put into storage in a safe way over the next, and will be stored safely for the next few years as the family 1 carries on operations, and they will be brought out of storage to replace the family 2 in the coming years. So what does MTG to bring us? So sorry, I need to move that over there. So Meteosat Third Generation Imager 2, it will complete the first family in orbit. There'll be significant enhancement over the second generation satellites. So, for example, the Severi versus the flexible combined imager that we now have on the third generation. So here, just a few examples of the increase of performance. So in the visible channels, the spatial resolution has gone from 1 kilometer to half a kilometer. There's an increase of channels, 12 to 16. We now have a flexible modes. So the full disk scanning service of 15 versus 10 minutes now that we can do for the whole Earth disk. And then, of course, there's a rapid scanning service of Europe. And I don't know why this has stopped. Anyway. Also, we've got a groundbreaking scientific data from the Lightning Imager. So this will typically be running on and continue running on MTG-I1, which has shown its value over the last few years. And of course, where ESA has really been involved is all the technological advancements that have been necessary to make these instruments come true in order to help contribute to the ability for more advanced nowcasting, forecasting abilities, and the extreme weather monitoring services provided by EUMETSAT. So the technologies is where it's at for us. So as we can see here, sorry, So it'll be the second imager launched. It'll be a 3-axis stabilized satellite, which will have a much improved pointing accuracy. And the stability is absolutely quite incredible of this beast that's 36,000 kilometers away. It has to be pinpoint accurate. Has a nominal lifetime of about 10.7 years, and the Imager 2 will be located at 9.5 degrees east. It will be 3.8 tons at launch, and then once deployed, as we can almost see in this image here, so it won't quite be as deployed as the video shows here, but it'll be quite big at 11.2, 6.5, and 5.3 meters once deployed up there. It's got a power consumption of 2.2 kilowatts, so 1.1 on each wing, and a much improved data downlink speed of 200 megabytes per second. But of course, none of this would be possible without the industrial consortium. And so over the years, we've been working with Thales France since 2010 when we kicked off this consortium. So the first MTG-I1 that was launched back in 2022 on an Ariane 5 from Kourou, that took 12 years to develop and build and test, again, with all of these people that have been involved. So 70 plus companies. We've had over 200 subcontracts, and at its peak around about the 2015, 2016 time, we've had over 2,000 people in Europe who've been employed working on Meteosat Third Generation. So important to point out that it's not just one company, us with Thales France. There's also been Thales Italy who've been involved with the DCS and GeoSAR, the very important data collection service and the search and rescue instruments, as well as Leonardo for the Lightning Imager and OHB Bremen for the platform, which is used for all 6 satellites. And so just a couple of tributes here with the pictures from the Ariane 5 launch in the top left and the Ariane 6.2 launch, the family pictures that we took just a couple of days ago in the clean room here in Kourou. And so as Caroline said, we are now prepared for launch. We've done all the standalone phase. The satellite has been completely checked out. It's working absolutely perfectly from our point of view. We've done the propellant loading that took a week to do because there's quite a lot of propellant on board, because after Ariane separates us after the separation from the Ariane 6.2 launcher, we still have about 10 to 12 days to go to get to the geostationary orbit itself. So there's quite a lot of propellant used in that phase. So we're all good to go, and we're looking forward to receiving more images like the one you can see here, which was the first image from MTG-I1, which is a sped up 24-hour phase. So thank you very much for listening, and I'm going to hand over to Olivier Brise now.
Are you handing over to Olivier or perhaps Susanna first?
Oh, Suzanne, sorry, excuse me. Excuse me.
From EUMETSAT, Suzanne, would you like to take over? Thank you.
Yeah, let me first try to share. So I will share my slide. So good morning. Good afternoon. I'm Suzanne Medita from EUMETSAT. I'm the MTG System Manager. So I'm very happy to be here with you today to celebrate the upcoming launch of the last satellite of the first MTG family, as already said, the MTG-I2. The MTG constellation is the most complex and innovative geostationary satellite system in the world, and it will be operated routinely by EUMETSAT. So if we look in terms of environmental concerns, the WMO State of Climate Report in 2026 confirmed that the last 11 years were the hottest years on record. After the record-breaking heat in 23 and 24, 25 is now ranked the warmest year ever observed, and the trend is accelerating. Actually, June 26 was the hottest June recorded for Western Europe and the second warmest globally. It's so near record temperatures driven by the highest sea surface temperatures, which as reported by the Copernicus service. And actually, very high temperatures quickly lead to drought and fires, as we have all seen in the past weeks in North America and also in Europe. In France, 120,000 hectares have already burned since January 26, and Spain has lost over 200,000 hectares to wildfires, forcing hundreds and thousands of people to evacuate. Both countries display a record amount of carbon and microparticle emissions, which are also health hazards. Actually, the climate change is making extreme weather events more frequent and more intense. In this context, climate protection is disaster protection, actually, and it's all about safeguarding lives, health, and livelihoods. In fact, satellites are one of our most powerful tools to face and monitor this reality, and the new generation of the Meteosat satellites now being deployed is designed to give societies earlier warnings and better insight into what is happening in our atmosphere. So the MTG system, which is what we're talking about today, that's why we are putting so much effort into it. It's the most complex and innovative meteorological geostationary system. There are two different types of satellite, as already mentioned. So we have a sounder and an imager. They will revolutionize numerical weather prediction and the nowcasting, which is what is helping for them to observe the high impact of extreme weather in Europe and Africa. The MTG system is fully operated by EUMETSAT, who also disseminates its data and ensures it reaches users in a timely and efficient way. Although not yet fully operational, the system currently with one imager and one sounder which are already deployed, has started to demonstrate the scope of the positive difference it makes for weather forecast and scientists monitoring the climate in the Met offices of EUMETSAT. So there's an increased spatial and temporal resolution, which enables the use of satellite data to visualize and monitor very detailed structures in the clouds and the atmosphere, which were not visible with the previous family of MSG. MTG also brings an improved observation quality that enables use of satellite data to see interesting phenomena more clearly. And the vast increase in the quality, quantity, and also frequency of data provided by MTG is helpful to improve the accuracy and the timeliness of nowcasting. This is crucial to protect lives and property against the most severe impact of weather events, such as lightning, high winds, heavy rainfalls, and flash floods. And we can also observe wildfires. The MTG-I2, which will be launched next week, will close the first family of the constellation, and we will hear a bit more from the UK Met Office on more of the applications. Combined with Meteosat 12, which is MTG-I1, the first imager launched on 13th of December 2022, and with MTG-S1, the first sounder launched on the 1st of July 25. The constellation is expected to become operational before the first quarter of next year. So as the last building brick on this constellation, MTG-I2 is seen as the enable satellite. It will enable the member states to benefit from this FCA spatial resolution imagery of the atmosphere. And about Africa and the north of Europe, and to help to track rapidly evolving phenomena like convective storms with a much finer timing. This is essential for nowcasting and the possibility to issue early warnings as early as possible and as reliable as possible. The high frequency of data will also enable better tracking of wildfire hotspots, smoke transport, dust, volcanic plumes, and help the civil protection and aviation routing. Ultimately, higher frequency images enable more and better atmosphere motion vectors like winds, improving regional numerical weather prediction, analysis, and very short range forecasts. So in conclusion, on this nice animation, the technology and knowledge development in the context of the third generation of the Meteosat satellites are crucial to advance our capacity to better forecast and monitor the weather and the climate, and to ensure Europe's technological sovereignty and autonomy. Indeed, MTG is a success of Europe, as already mentioned. It combines the competence of EUMETSAT, ESA, and industry to deliver the most valuable Earth observation satellite system in the world for more accurate and timely forecasts, with direct impacts on economies and societies. This is the key of the current context in the climate change, generating more frequent extreme weather situations. And with this, I conclude my presentation. Thank you.
Thank you very much, Susanna. And as you might have heard, for those of you who don't know exactly what's happening where we are, at least 3 of our speakers are currently in Kourou, so there are ever so often announcements from the spaceport that you might hear in the background, but it's all normal. Please don't be alarmed. Now over to Olivier, who is among actually the speakers in Kourou. Thank you very much.
So good afternoon to everybody. Yes, we can tell you that, for example, there are some hazardous activities currently, and we are preparing the satellite for the last journey to the EFA building. So this is why sometimes there are some announcements. As an introduction, I would like to remind to everybody that for Thales Alenia Space, this is a long story. Meteosat is a long story because it was the first prime contractor from INCAN for any satellite activities. We have built up to now up to 13 satellites, and this MTG-IFM2 will be the number 14. And we have accumulated more than 115 years in orbit of success. To remind to everybody, technically speaking, we are talking about the geostationary orbit, but for this specific generation family, we have a 3-axis stabilized satellite, which allows to accommodate few additional missions than the one which is a key mission. So we are talking for the Imager about 5 payloads on board. The famous flexible Imager, which allows, in addition to the nominal mission, some scan of dedicated areas if needed. You can see here in the pictures the evolutions of the quality and the performance of the images provided by the Imager. We have also a Lightning Imager, which is the first in Europe, first application in Europe, and also some additional missions. The data collection, which is an enlarged capability versus the 2nd generation, Meteosat 2nd generation. The famous radiation monitoring unit, which is also a classical experience implemented in most of the ESA missions. And the science data downlink, we are talking about 200 megabytes per second. So this is why you are using a Ka band spectrum. We have few key advanced technology, which are the challenges to meet the performance and the mission. We have here reminded only 2 of them, which is first of all the development of the scanning subsystem with some spectrum in order to allow spectral channels, the repeat cycles, the real solution, which is adapted to the meteorological applications. And of course, it's very important for the science data quality and the performance of the images provided by the mission, which is a fine pointing mode, which allow a very accurate pointing stability. Because and taking into account the very sensitive, taking into account that the satellite is and the performance are very sensitive to any perturbation, we have developed dedicated vibration filtering devices in order to filter and to damp all the perturbation on board. The flexible side, the flexible Imager inside, 16 spectral channels, 8 classical in the visible and the near infrared, but 8 in addition, 8 thermal channels cooled at 56 Kelvin. A focal length very small, thanks to the set of lens and mirrors which are accommodated inside, and the classical scanning system already presented previously. Nominal mass 450 kilo, average consumption 500 watts only. The Lightning Imager, which is different technology than the one used the Imager. For example, there is no scanning. It is 4 fixed telescopes, each of them covering a set of regions, and you can see here the Red Sea. Yes, the Red Sea seen by the Lightning Imager. So integration time 1 milliseconds, a bandwidth of 330 megabits per second, and a timeless of 30 seconds. And also very important, the efficiency on board, because for the Imager, all the data are downloaded on ground for the further computations. Here we have the computation which is first performed on board with a detection efficiency of more than 90%. For example, you can imagine that on board there are per second 100 million detections which are filtered and analyzed on board. The classical data collections and search rescue payload, which are from the DCS, the classical is operated by EUMETSAT, providing connectivity to and data collection from remote terminals. And the other one, which is also for the COSPAR CARSAT humanitarian mission, which is for the rescue, which is an essential element for the for any rescue activities. Concerning the activities in Cannes, in Thales Alenia Space, there are more than 18 months and some images of the activities. So after the launch, the successful launch of the PFM, we have performed a short storage phase before resumption of the activities, integration of the FCI FM2 and optical vacuum test. We have performed a thermal vacuum test. We have performed 2 of them. The last was completed just 1 year ago. And in parallel for Thales Alenia Space team, in parallel with the same team involved in parallel to the MTGS PFM launch and operation. We have performed classical mechanical environmentals, mainly acoustic, physical properties and deployments. And the final test sequence occurred with mainly RF autocompatibility and optical test. And you can see here the final solar array integration before storage and arriving transportation. For the final activities after the final AIT activities, so completed step was transportation from Nice Airport to Paracabo Airport in French Guiana, thanks to the Toucan. Arrival early June and with the storage up to early July. Then we have resumed the activities to complete all the standalone activities. We have completed the propellant loading last Friday successfully with a good team spirit. The next steps are to come with the launch itself, and then for sure all the activities which are related to the low Earth orbit operations in Fucino, managed by EUMETSAT. And all the people are ready to travel next Monday to cover 13 days of activities from 27th of August up to 8th of September in order to lay the floor to EUMETSAT in Darmstadt. And the commissioning to confirm the in-flight performance is foreseen into early 2027.
Yeah.
So it will be 50 years after the launch of the first Meteosat. Another activities which are also completed thanks to the Thales Alenia Space expertise. It is a science data quality because we have provided support to EUMETSAT in order to complete the geometric model to the performance of the geometry. The principle is to take into account all the dynamic estimation of the image geometry in order to keep the geometry model accurate using both onboard measurements, which are satellite attitudes, scale measurements, and also some other parameters which are key for the performance on board, and the features extracted from the image, which is with the known location, for example, the coastline, stars, landmarks, which are able to help us in order to re-estimate and to reevaluate the geometric model to have an accurate pictures at the end, images at the end. And I think that's it for the. Thank you for your attention.
Thank you very much, Olivier. And to conclude this first round of introductions, we will have one from Thomas, who will give us the application really of the satellite and how it will improve forecasting. Thomas.
Okay, hi everybody. Yes, I'm Thomas Blackmore. I'm a science manager of the Space Data Products and Systems team at the Met Office in the UK, and I'm here to give the user perspective on MTG-I2. So for us, the upcoming launch of the MTG-I2 satellites is a really important step forwards for weather monitoring across Europe. As a national meteorological service, what's exciting us most about this satellite is its rapid scanning capability. So as we've heard from the other speakers, MTG-I2 will provide imagery over Europe every 2.5 minutes, which will allow us to observe rapidly developing weather with unprecedented frequency and detail. Okay, so as we've heard also, the first MTG imaging satellites already above us, orbiting 36,000 kilometers up there in space. That's providing us with incredibly detailed high-resolution imagery across the full Earth disk every 10 minutes. And we're seeing real tangible benefits from that data already in our Met service. MTG-I2 is going to take this a step further by giving us a much more frequent and timely view of the atmosphere, and crucially, that's at that same high resolution of the first imager. As you're, of course, aware, weather's constantly changing, and that's especially true during high-impact weather events. So these more frequent these more frequent observations mean that forecasters can follow the changes as they happen, rather than having to wait several minutes for the next image from space. And of course, rapidly evolving weather doesn't tend to hang around and wait for 10 minutes. So having those frequently updated images is really important. So for forecasters, MTG-I2 is a bit like moving from having a series of snapshots to having something that's much closer to a live video stream from space. So these rapid updates are incredibly valuable for situational awareness and for short-range forecasting. A really good example of this is severe convective storms. These massive storms can have a significant impact both on the ground and to aviation. And so these big thunderstorms intensify very quickly, bringing a multitude of different hazards such as heavy rainfall, lightning, hail, damaging winds, flash flooding, and effects on aviation from like overshooting tops and other effects within the thunderstorm clouds. So if we've got imagery every 2.5 minutes, the forecasters can spot the areas of developing convection much earlier and follow the evolution much more closely. So that allows them to monitor cloud top cooling, storm growth, and changes in the structure of the storms at a much higher frequency and with much greater confidence. So this gives us much earlier signs of where the severe storms may be developing and allows us to track them in near real time. Because when a big thunderstorm intensifies in just a few minutes, observations every 2.5 minutes make a real difference to situational awareness and very short-term forecasting. So in practical terms, this improved situational awareness provided by MTG-I2 can support earlier decisions and greater confidence when you're monitoring and warning for potentially high-impact weather. That makes a big difference for people in the path of the severe weather, as well as for emergency planners and responders. When you have earlier and more accurate warnings, it can make a big difference to help protect lives and livelihoods. So here at the Met Office and across other national meteorological services throughout Europe, we're busy preparing to use the data from MTG-I2 once it's available to enhance our services with the aim of helping people, businesses, and governments make better decisions to stay safe and thrive. Of course, the launch is only the beginning. Once it's in orbit, MTG-I2, as has been mentioned, will complete the Meteosat Third Generation constellation. So it's going to be complementing the capabilities we already get from the other MTG satellites, the first Imager satellite, which provides the full disk scanning service, and the sounder satellite, which are already in space. This will help us build an even more complete picture of the atmosphere and surface conditions across the region. And it's also going to strengthen the resilience of the system as it can provide a backup to the full disk scanning service if necessary. So by combining all these complementary observations, the forecasters gain a richer and more complete understanding of the atmosphere, which really helps them when they want to monitor hazardous weather more effectively as it develops. So I guess ultimately, MTG-I2 is much more than just a shiny new satellite. It's going to help meteorological services see rapidly evolving weather much more clearly, to monitor severe weather such as large convective storms more effectively, and to provide better information to decision makers and the public when it matters most. And I'll leave it there. Thank you.
Thank you very much for that. I'll put all our panelists now on view so that you can all see them. We're about to move to the question and answers part of the session. I've just written some notes in the chat so that journalists know what to do, but you can essentially either raise your hand if you have questions, or you can write them in the chat. You can also just simply write your name and your media outlet in the chat, and we'll give the floor over to you. Just note that, of course, when I give you over the floor, you will get a prompt on your screen. You'll have to accept it in order to unmute yourselves. So are there any questions? We'll give you a minute or two to see if you have any. Oh, perhaps. Aha, I see that Will Robinson Smith has a question. I'll hand over to you. And if you don't mind, please make sure that you state your media outlet. You should have received an unmute request.
Yes, can you hear me all right?
You're very low. You might have to get closer to the microphone.
Okay, is this any better?
That is better. Yes, thank you.
Okay, perfect. Quick one to Olivier regarding the commissioning work, excuse me, after launch. How soon into that process do you expect to get the first light images from this satellite? And then quick question to Caroline from Ariane Space. Can you give an overview of what the rest of the year looks like after this mission for the company, and look into 2027? How many launches are you expecting, and for whom? Thank you.
Thank you, Will. I just want to point out perhaps that Will is from Spaceflight Now. Thank you.
Yes, thank you.
So perhaps Olivier first.
Yes, so concerning the first part of the question, it is when we will receive the first image. There will be the first activities after the arriving in orbit and after the LEOP. So after the 8th of September, we will switch on the imager. Then there will be more than, almost, I would say, 6 weeks of outgassing. So we'll not take any picture. And then there will be the first, we'll start the first acquisition. And I let the floor to Suzanne to tell you when you will get the first formal and official picture images.
So I said we first have to do the outgassing to clean the instrument from any particles and humidity which it brought up with from ground. Then there are a lot of several activities to do to start the instrument, to calibrate, to check that all the mechanisms are working, and to get down the first images, which are completely calibrated. So we also have to put everything, as Olivier was showing in one of his last slides, to understand what the characteristics, that what we measured on ground is the same as we measure on board. So that there are quite a lot of activities to be done. I cannot give you a precise date for the first image, but what I can tell you is that for MTG-I1, it took 4 months to get out the first image. Now, I2 being a recurrent satellite, we intend to do it quicker, but for I1, it took 4 months.
Thank you very much, Susanna. And I guess, Caroline, then it was over to you.
Excuse me, I was on mute. So this year, as I mentioned, MTG-I2 launch will be the 4th Ariane 6 of the year, and I would say that the target of the year remains unchanged. We target 7 to 8 Ariane 6 launches before the end of the year. But with regard to the precise missions we will deliver before the end of the year, we will come back later and step by step to this point. But target unchanged for 2026, and from 2028 we will be in a stabilized phase, we can say, and we target from 2027, 9 to 10 launches per year, both Ariane 62 and Ariane 64 launches.
Thank you very much, Caroline. And I just want to let the media know that we're joined by actually 2 additional experts who are here to answer questions, should the questions be on topics that are a little bit on a wider scope scoped in this mission. Paul Cooney from EUMETSAT, Head of Strategy, Communication and International Relations, is also joined us, and Louis Laurent, the Head of the Ariane program from the European Space Agency, is also here. Now, I don't know if there are further questions so far. I see that most of your questions. Oh, Jeremy Wilkes from Euronews. Jeremy, I will open the mic, otherwise I will read out your question. So perhaps you want to ask it yourself. You are muted.
Hi, Adelina.
Hi.
Hello. Hi, Adelina. Thank you. Yeah, it was a question about the lightning observations. I'm just wondering what impact that would really have in the weather forecasts. Does it change what people, the average European, will see on their weather forecast? Does it help keep people safer? What's the point of having such detail on the lightning?
Thank you very much, Jeremy. I don't know if that would be for perhaps, yes, Thomas, you would like to answer that?
Yes. Hi, Jeremy. Well, what we found with the lightning imager is that it's very complementary to the ground-based observations of lightning that we have. We have the lightning network over parts of Europe. Europe gives good indication of cloud-to-ground lightning, but the lightning imager on Meteosat 12, the first Meteosat Third Generation Imager, gives us much better overall lightning coverage, so cloud-to-cloud lightning as well. That's really important for aviation and other applications. Also, we find that you talk about how it will change what Europeans see. The ground-based networks often only cover Europe and other places like that. Africa will benefit a lot from the lightning imager because they get better lightning detection than they can get from any ground-based network currently through this imager from space. So it will also be benefiting people in Africa as well as Europeans.
Thank you very much, Thomas. I see that we have a question from Alex Pack. Alex, I've sent you an unmute prompt, so you should be able to ask it yourself. Otherwise, I'll read it out for you. I'll give it a second.
Hello, can you hear me?
We can hear you. Thank you.
My question was to the Met Office mostly. So many meteorological agencies are increasingly incorporating AI into their forecasting systems. So I was wondering how the additional data provided by the new satellite will improve AI-based weather models, and are there any specific applications where you expect the greatest impact?
Hi, Alex. Yes, so yeah, as you say, there's a lot of work on using AI increasingly in forecasting systems. Fairly early days, but Met Services are making a lot of progress and finding some very positive results so far. What we're finding is that often the more data that we can provide to an AI forecasting model, the better. So having this increased frequency of data from MTG-I2 will potentially be a benefit. It's not something we've experimented with specifically so far, but as a general picture, I can see that this extra data is going to be very beneficial. In terms of specific applications, it's those very short-term forecasts. So as well as the kind of main forecasting models that we run, we have a lot of what we call nowcast models, which are very short-term forecast models, and we're also incorporating AI aspects into those, or at least experimenting with that currently. So I think the rapid update from MTG-I2 will potentially have the biggest impact in those nowcasting AI-based weather models, and they'll give the impacts of, like I talked about, the severe convection, large thunderstorms, things that are going to you can generally with a traditional numerical weather prediction model, you get a good idea that there's going to be thunderstorms in a particular region or area, but you can't say exactly where that storm is going to form. You can say there's the environment is such that those storms are likely to form, but as we improve our models, and AI is one of the ways that we might improve these nowcasting models, we might get more specific about exactly where those storms are going to form. We'll get information about the environment, the preconvective environment, and so on. So we'll have a better idea of exactly where the conditions are right for those storms to form and really develop into something serious.
Thank you very much, Thomas. For those of you who are interested in the mission kit, I've actually put a link with regards to the MTG-Imager so that you can look at and you can have information on while we wait for further questions. A media kit specifically on the launch will be soon available. We'll share that link with you as well, either today or tomorrow. We should have it shortly. And let's see if anybody else has a question with regards to the upcoming launch. Please let us know, otherwise we'll end the session a little earlier than expected. But I guess our panelists have shared a lot of information and have been very exhaustive in their presentations. I see that Jeremy has another question. Jeremy Wilkes from Euronews. Jeremy, would you like to ask it yourself?
Yeah, on my Twitter X feed is full of chat about El Nino. I'm wondering whether the satellite will be ready to observe the effects that we might see in the beginning of next year from the El Nino, and what kind of impact or value added would it have, would the additional capabilities that we have on the satellite actually bring to what we can see on the horizon at the moment.
Thank you, Jeremy. I think is it Susanna that's going to answer?
Yeah.
Okay.
I can try to start the answer. El Nino is more in the Atlantic, so MTG-I2 is more dedicated to the rapid scan above Northern Europe, Northern Africa and Europe. Nevertheless, MTG-I1 is already able to observe El Nino. So yes, we have better images, and it's mainly the sea surface temperature also. So with the MTG-I1, we can observe El Nino, and then we have also the LEO satellites who complete the observation. So MTG-I2 is not really, but we already have one working on this.
Thank you very much. And I see that we have another question for Will Robinson-Smith from Spaceflight Now. Will, you should be receiving as well another prompt to unmute and to ask your question. Thank you.
Yes, thank you for allowing a second one. This to Suzanne or James. Given that this will round out the first family, and please correct me if I'm mistaken on this, the second family is being put in reserve to augment and replace these satellites when they're reaching the end of their intended lives. Looking beyond this third generation, when you're imagining the fourth generation of MTG, what types of capabilities are you working on now that you want those satellites to be capable of, that this generation is either at the maximum of, or sort of pushing the boundaries of? I guess just where do you want to go from here? Thank you.
Okay, well, maybe I start. So yes, so the second family, so the second set of triplets will be taken out of storage in round about 2030 to 2031, ready for launching in 2033, 35 and 36. But of course, in between then we'll have collected an awful lot of data from the first family, and that will give us a great insight, together with EUMETSAT, together with the Met offices, as to what the users are finding good, what they're able to exploit properly, and of course they'll come with more and more questions. Oh, can we do this? Can we do that? Can we do the other? And it's that process that we want to start working on with EUMETSAT in the coming years, in order to be able to build on the needs for the fourth generation that we are very, very well aware that we'll need to start preparing for in order to replace the MTG family 2 in the 2040s. So this process is very much to the forefront. Exactly what capabilities and needs, it's hard to say at the moment. What's for sure is there will be another flexible combined imager enhancement coming, and I'm fairly certain that the sounding capability from geostationary orbit, which is a game changer that's been in orbit for the last year, is going to be loved by many users. So we'll be enhancing these as well, but to the actual extent, I'm not quite sure. But maybe Suzanne, you would like to complement this from EUMETSAT's side.
Yeah, thank you, James. From EUMETSAT's side, I think Paul, because he joined, may want to comment.
Okay.
Maybe I can take this one. So you explained it very well, James. And what's very important at EUMETSAT is that the program are always driven by the needs of the user. So typically the representative of the Met Office is part of the users. And we have started this conversation with our users. But of course, we cannot start too early because we first need to see what MTG will deliver when we have the full system of MTG. But the discussion is ongoing. We are planning a replenishment of the full constellation in the 2040 timeframe. And when you see the development time which is needed for such it is really the right time to start. But again, we cannot be too fast because first we have to learn from what we will be launching this week.
Thank you very much for your thorough answer, and thank you, Paul, for joining to provide further information. I'll just give it a minute to see if we have any further questions from the journalists who have joined us today. In any case, we'll make sure this this briefing has been recorded, so the recording will be made available to you, as will the slides. Please let us know if you need to have them with the animations or without, because we'll actually distribute them as PDFs. But if you need the animations, we'll make sure to send them to you as well. And you can reach us at media@esa.int. If you need anything else or have further questions, please send them to us and we'll redirect as needed, either to EUMETSAT, Ariane Espace, Teleslinia Space, or the UK Met Office. I see that there's certainly a demand for the animations, so that's good to know. And given that I don't see any further questions, I think we'll close this session here. Thank you very much to our panelists for joining us, to the expert speakers who also joined us just in case there were additional questions, and to the journalists for joining us in the middle of August when many of you are working additional hours. So much appreciated. Have a good afternoon, everybody. Thank you.
Thank you, Adelina. Thank you. Bye-bye.
Yeah.
Bye-bye.
Bye-bye.
Bye-bye.